The seatbelt sign illuminates with a familiar chime. Your stomach drops as the aircraft suddenly lurches. For many passengers, turbulence represents one of flying's most unsettling experiences. Yet it remains one of the least understood phenomena of air travel. Turbulence is essentially rough air, similar to how a boat encounters choppy water on the ocean. When an aircraft flies through the atmosphere, it's navigating an invisible ocean of air that's constantly in motion. These movements create disturbances that affect the plane's smooth passage through the sky. The atmosphere contains countless air currents moving at different speeds and directions. When these currents collide, separate, or flow over obstacles like mountains, they create eddies and waves in the air. As your plane encounters these disturbances, it experiences changes in lift, which is what keeps the aircraft airborne. When lift suddenly increases, the plane rises slightly. When it decreases, the plane drops. These rapid changes create the bumpy sensation we call turbulence. Think of it like driving a car over a bumpy road. The car itself remains structurally sound, but the passengers feel every undulation in the pavement. Similarly, an aircraft experiencing turbulence isn't damaged by these air movements, but passengers definitely feel the motion. Types of turbulence. Not all turbulence is created equal, and pilots categorize it into several distinct types based on its cause and intensity. Clear air turbulence is perhaps the most notorious because it occurs in cloudless skies with no visible warning signs. This type happens when bodies of air moving at significantly different speeds meet, typically near the jet stream, those high-altitude rivers of fast-moving air that planes often use to reduce flight time. The boundary between the jet stream's powerful winds and calmer surrounding air creates invisible turbulence that can catch even experienced pilots by surprise. Mechanical turbulence occurs when wind flows over or around obstacles like mountains, buildings, or even other weather systems. As air is forced to navigate these obstructions, it becomes chaotic and turbulent on the downwind side. This is why approaches to airports near mountain ranges can be particularly bumpy. Convective turbulence happens when the sun heats the Earth's surface unevenly, causing air to rise in columns called thermals. These rising currents create instability in the atmosphere, particularly on hot summer afternoons. Flying through or near thunderstorms intensifies this effect dramatically, which is why pilots give storm systems a wide berth. Wake turbulence is different from atmospheric turbulence. It's created by other aircraft. Every plane generates vortices from its wingtips, particularly during takeoff and landing. These spinning air currents can persist for several minutes and affect following aircraft, which is why air traffic controllers maintain specific separation standards between planes. What happens inside the aircraft? When turbulence strikes, several things occur simultaneously. The plane's wings flex and bend, absorbing much of the force from the disturbed air. Modern aircraft wings are designed with remarkable flexibility, able to bend several feet in either direction without sustaining damage. This flexibility is a feature, not a flaw, allowing the wings to absorb forces rather than transmit them rigidly through the airframe. The autopilot system, if engaged, continuously makes small adjustments to maintain the aircraft's programmed altitude and heading. However, in moderate to severe turbulence, these automated systems can't compensate for every air pocket and sudden shift. The plane may gain or lose altitude by tens or even hundreds of feet in seconds, though this represents a tiny fraction of the vertical space allocated to the aircraft by air traffic control. Inside the cabin, unsecured items become projectiles. This is why flight attendants secure service carts and why passengers are advised to keep their seatbelts fastened throughout the flight. Most turbulence-related injuries don't result from the turbulence itself, but from people or objects being thrown about the cabin. The pilot's primary concerns during turbulence are passenger comfort and safety, rather than the aircraft's structural integrity. Pilots may reduce speed to the designated turbulence penetration speed, which minimizes stress on the airframe while maintaining safe flight. They communicate with air traffic control to request altitude changes or route deviations to find smoother air. Other pilots flying the same route often share reports about turbulence locations, helping everyone avoid the worst areas. The safety reality. Here's the reassuring truth that many nervous flyers need to hear. Turbulence has never caused a modern commercial airliner to crash. Aircraft are engineered to withstand forces far greater than any turbulence can generate. Before certification, planes undergo extreme stress testing, with wings bent to angles that would never occur in actual flight conditions. The Federal Aviation Administration requires aircraft to withstand forces 1.5 times greater than anything expected during normal operation, including severe turbulence. Manufacturers then add their own safety margins on top of these requirements. When you see videos of wings flexing dramatically during testing, those represent forces multiple times greater than what severe turbulence produces. Modern aircraft are also equipped with sophisticated radar systems that detect weather patterns and precipitation, helping pilots identify and avoid turbulent areas. While clear air turbulence remains largely invisible to radar, pilot reports and improving forecasting technologies help flight crews anticipate and navigate around these areas when possible. The most significant risk from turbulence involves injuries to passengers and crew who aren't wearing seatbelts. During severe turbulence, unbuckled passengers can be lifted from their seats and thrown against the ceiling or into hard surfaces. Flight attendants are particularly vulnerable because their duties often require them to move about the cabin. This is why pilots typically halt cabin service when they anticipate rough air ahead. Why does turbulence feel so alarming if it's not actually dangerous? The answer lies in psychology and sensory perception. Humans evolved on solid ground, where unexpected movements often signaled genuine danger. When we're suspended 6 miles above Earth, our ancient survival instincts kick into overdrive at any unusual sensation. The lack of visual reference points intensifies this feeling. Unlike a car ride where you can see bumps in the road approaching, turbulence is invisible and unpredictable. Your body feels motion that your eyes can't explain, creating a disconnect that many find deeply unsettling. Additionally, many passengers misinterpret normal sounds during turbulence. The clunking of overhead bins, the creaking of the airframe, and changes in engine tone are typically just acoustic effects of the plane's various components moving slightly, or pilots adjusting power settings. These sounds, while unfamiliar, don't indicate anything concerning. Aviation technology continues to evolve in ways that may reduce turbulence encounters. Advanced forecasting models increasingly predict clear air turbulence with greater accuracy. Some aircraft manufacturers are developing systems that detect turbulence ahead of the plane and automatically adjust control surfaces to counteract the forces before passengers feel them. In the meantime, understanding what turbulence actually is, a natural atmospheric phenomenon that modern aircraft handle routinely, can help transform it from a source of fear into merely an inconvenience. The next time that seatbelt sign illuminates and the ride gets rough, remember that your plane was built for exactly this situation. The pilots are trained for it, the aircraft is designed for it, and thousands of flights navigate similar conditions safely every single day. Turbulence may rattle nerves and spill drinks, but it's simply the atmosphere reminding us that we're traveling through an ocean of air, one that's constantly moving, shifting, and very much alive.